morning, one and all. On behalf of the Institute, I welcome Professor Ashok Pundir, who is Professor in Operations Management at NITI Mumbai, for conduct of pre-submission, two pre-submission seminars. The first one is on modeling quality cost management system in advanced manufacturing environment. The PhD scholar is Mr. Sanjay Mantri under the supervision of Dr. Jaju. And the second one is data-dependent modeling and analysis of the rejections in duplex mold casting by Mr. Ghrce under the supervision of Professor D. J. Tikke. So, with the permission of the expert, can we begin with the presentation? Yeah.
On the on-site, requested expert, Pundir sir, and all faculty members, my mentors from Ghrce Engineering College, Krislani sir, HOD Warke sir, Pankere sir, Jaju sir, and Tilke sir. I am here to present my pre-submission seminar on the research work conducted in this institute on modeling of quality cost management in advanced manufacturing environment. Yes. Scheme of the presentation. So, before going through this particular presentation, I would like to specifically tell what exactly I have done in this particular in short, and then we will go through a presentation. So my study consisted of two major parts. One is the actual industry practices that I have studied, and second, I have modeled the quality cost management system, and that I have implemented in a case study. So my total research work is spread over these two aspects where I have done. So in scheme of presentation, first is the origin of research, then literature review, research methodology, study of actual industry practices for cost of quality. So actually this is an additional step. In conventional methods, you find that we go for research methodology, then development of whatever model we want to develop. But this is an additional thing. We can say that this is parallel to literature review step. In literature, we study the whatever is published, and here I thought that I should go to the industry and try to get whatever existing practices there. So that is a additional thing that I want to highlight here. Otherwise, the flow is as per the traditional lines. Now, from where this idea I have got, literature review, at that time, I have gone through one survey paper in 2011, where the actual cost of quality practices in India, there was some survey done, and there was less penetration in the industry, whereas this particular field is open from last 60 years. Theory is established, but it is not being used. So it has created an interest in me that I should explore this particular area. And then I have contacted some experts. Dr. Lakhe is a local expert. I talked with him, then with Jaju sir, and then we have finalized about this topic. And then I have contacted some industry persons. They are very keen. Whatever, when quality word comes, they are keen in any new tool to take. And they said that yes, there is a need. We have heard about this, but we have not implemented. So I have decided that I should go for this particular work. So this was a driving force, lack of awareness and penetration in the industry at that time. Now what is the quality cost? These are the definitions. One standard exists, but this is very old, 1995 standard, not revised yet. It says that quality costs are expenditure incurred in defect prevention, appraisal of the quality efforts, then internal failure and external failure. Then ASG, it is a American Society for Quality. They have got slightly broader definition. They say that this is a methodology. Cost of quality is a methodology itself, and they have covered products as well as services under the purview of quality cost. So basically, having this information for any organization, it determines the potential saving that the industry can achieve, and there will be a continuous improvement simultaneously. So quality related activities that incur cost may be divided broadly in prevention cost, appraisal cost, internal failure cost and external failure cost. So this is by basic definitions that are available. Now my title says that I am going to develop a quality cost management system. So what I am referring to? I am referring to quality cost management system. It defines practices, policies and procedures followed by an organization on these three lines: collecting, measuring and classifying the quality cost data, that is the first thing. Second thing, analyzing, reporting, there may be a schedule for that, and use of that quality cost data. And then we have to generate certain quality related financial matrices. Actually quality related different information is there, but if this quality information is converted into the financial information, then upper management gets lot of interest in that, and that's why there is the importance of this process. Now what is the scope of my work as far as the advanced manufacturing environment is concerned, because this is very broad word, you can say. So one of the study I have seen where he has defined it like this: advanced manufacturing environment is a manufacturing environment including manufacturing technologies using computers and information technology systems such as LAN, WAN, ERP and MIS. This is one of the area this development has caused ease of implementation of this particular methodology as compared to the previous periods. So my context of advanced manufacturing environment is an industry where you are having a proper information system, a proper management information system and network databases, a central database which has got a network of all the departments. Now, a business enterprise in such an environment is subjected to a continuous update and development. That is the feature of this particular environment. However, with the change in the manufacturing environment, this quality cost management practice still needs further improvement, and that is my topic. So, at this point, there was one conference in that I have presented a model, whatever I have proposed. So, overview of my research work. I want to develop a quality cost framework, quality cost management system framework for an enterprise which is being working in advanced and computer integrated manufacturing. So these are the broad steps. Study of the present state of art from the literature, industry practices related to cost of quality, development of the cost of quality framework, study in the case industry, and generalization by application to the some other industries. For this, I went for exhaustive literature review. I have segregated papers on two themes. One is the global cost of quality practices. Other is the cost of quality practices reflected in the Indian publications. So there I got around 77 papers which reflect the global practices, 16 papers which reflect the Indian practices. Then out of that, with the context of my study, further I have filtered them to 68 papers, and mostly around 80% of these papers belong to these databases. These are peer-reviewed databases: Indian Science Expert, Science Direct, Imran, Keller and Francis, and IEEE. Out of this, final filtering 20 papers that directly I have used for implementation of this particular methodology.
So 93 was advanced manufacturing system?
No, 93 are on the
Overall.
global cost of quality practices, not on the advanced
Not on
manufacturing.
the advanced manufacturing.
Not on the advanced.
So how many were applicable in advanced manufacturing system?
Advanced manufacturing systems, the recent papers. Yeah. Yes, sir. Yes, it is okay. So advanced manufacturing implementation, that was a recent trend in this particular paper. So out of these 20 papers, there are few papers on advanced manufacturing. But basically I have to implement cost of
20 are
quality.
at least in manufacturing domain, whether advanced or whichever. But 20 belongs to manufacturing sector.
Basically all these belongs to manufacturing side cost of quality. Calculation of cost of quality for manufacturing side. Okay. Yes. So this is another classification. Review papers. There are 3 prominent review papers in this cost of quality with a gap of a decade, and they have been referred by a number of people. Then survey papers, this indicates the penetration. 10 survey papers I have studied, so these 10 belong to different regions. There are 2 from USA, 1 from Australia, 1 from Northern England, Malaysia, and 1 paper is from India, that is Chopra and Ghrce. Okay, and this cost of quality recent paper, these papers discuss the cost of quality and advanced manufacturing environment. So these are the recent papers. And finally, I have to implement it in the Indian context. So I have clubbed all the papers in cost of quality which are being published in India the last 10 years. So this is how I have classified. And then 1 paper, a review paper, I have published on this in Inter Science for this particular thing on the literature review. Then these are the research gaps that I have found out. Quality cost studies in India differ with respect to the developed countries on these aspects. Very few studies are conducted here. That is the first thing. Either maybe case study or maybe the surveys. Most studies reported are from small scale industry domain. Then alignment of industry quality management perspective to quality costing. This alignment is not there in India, whereas in other countries they are having this alignment. And there is a disconnect of actual industry practices to the literature. Now, reason for non-implementation of quoted previous studies are to be investigated in the present scenario. Whether in present advancement in the technology, can it help to overcome the difficulties which are quoted previously? And that is the final aim. QCMS is to be developed to take maximum advantage of advancement. So problem definition, it will be on the same line to that of research gap. That is adequate theoretical basis available, but practical usage is very less. Then industries follows, this is very important. The industry presently follow a lot of quality standards. They go on upgrading. But I have studied around 12 to 15 industries. Nobody says that we know quality cost standard is there or we are using it. So that is one of the problems. And this is not known to people. Benefit of this QCMS is not projected to industry or visible to the industry. So a researcher can work on that and he can project it. Then absence of comprehensive framework of QCMS. So objectives will be obviously aligned on the same line. Okay. So as the time constraint is there, I will quickly go through this. First, I thought of exploring cost of quality practices wherever I get opportunity, whether it is a small, medium, large size, and from different areas. I have tried to explore the practices, then develop a framework, then we have to validate by using a case study, and then generalization. So this is a quality cost. What is the effect of quality cost? Just it is illustrated. Now, effect of quality improvements and awareness. If we go on x-axis, you will find that the prevention, appraisal, and these all 3 components should go on reducing if there is a increase in the awareness and implementation. And here you see that prevention is a major portion and failure costs are minimum. Initially, failure costs are very high. So this is being given in another British standard on this one, quality cost. And these are 2 standards. One is a classical view of cost of quality. To explain cost of quality, these 2 figures are extensively used. What does it says? It says that as the quality level increases, you will find that the failure cost will go on reducing. But how this is going to increase? By increasing the expenditure on prevention as well as appraisal activities. And there you get the crossing of these 2 curves, and that is corresponding to the total cost of quality minima. This was a classical view, but recent literature says that this is not good. People will stop before 100%, and this is not valid. So now this is the modern view, where you say that there is a continuous increase in the quality level, there will be reduction to the total cost of quality. So this is just for the benefit of general viewers. What is the cost of quality? I have shown this. Now there are 5 different models available in the literature. Out of that, most popular being PAF model. Then these are modified form of the PAF models, where opportunity cost is added, intangible cost is added. Here, this is a process cost model, which is particularly suitable for process industries. So in Britain, there are two standards. One is a PAF standard, other is a PC standard. ABC, we don't have existing standard now. It is said that ABC is suitable for advanced manufacturing environment, with the caveat that the accounting system should be suitable for ABC type of models. So here, based on the model that we are selecting, it is classified, the cost categories are classified. That's why I have put this slide. PAF, it is classified in prevention, appraisal and failure. ABC, value added, non-value added, process cost, cost of conformance, cost of non-conformance. So now, this is a scheme by which I have undertaken the research. Based on literature review, I have proposed the QCMS framework. Simultaneously, I have started the study of actual industry practices, which has given me what are the best practices available. I can have benchmarking for my study, and what are the practical limitations, because in theory there can be so many things proposed, but there are practical limitations. And to this, case industry characteristics are to be merged to get the required customized QCMS, then data collection, data analysis and research outcome. This is how I have planned the research. Now this is a conclusion from the literature review that it is imperative to go for a development of QCMS, which takes into account the advanced manufacturing environment. The model should be suitable for the environment, and it should be it should solve the purpose that is being defined by the company. Okay, it should not be as per the standard of literature, but it should be useful to the company. That is my point of view. And use of information technology infrastructure should be utilized there. Now this is a draft of that particular framework, where we have clubbed activities in three categories. One, a pre-processor, second, a processor, and third one is a post-processor. Pre-processor is related to the basic data of the company. It may be a general information as well as a quality related information. Then what is the cost of quality status, whether it is existing, non-existing, and then after that we have to decide on the type of model. So this elaboration I will do, sir, when I will be discussing a case study, so that there will not be any repetition. Is that fine?
Yeah.
Okay? Because these three elements I have put on three different slides, but that will be a repetition. At the time of implementation, I will show you. Okay. Now, this is the interaction that I expect between the quality cost management system and all other elements of the organization. It will take quality cost data from different functions and departments, and it will also take quality cost data from ERP or MIS. In present case study, I have found that 80% of data is available in ERP and MIS, and 20% data is to be collected from individual functions or department. So it will take that data, it will process, it will generate the cost of quality matrices as defined by top management, because those will be defined by management. They will say that cost of quality should be this much percentage of sales and other parameters. So this will be given back to top management for their use. And QCMS, another important thing is it will give quality improvement initiatives to the different departments, because once that information is processed, it will show the problem areas where the more cost is incurred, and that will lead to quality improvement initiative. So this is overall interaction that is being expected. Now I will come to directly the first part of my research work, that is how I have gone for study of the actual industry practices. So methodology used was very simple. I have prepared a list of 10 questions. Those were open-ended questions, which will reflect the information about the cost of quality of that company. Second, once I have got a positive response, I have fixed an interaction with the contact person, and then detailed interaction I have done, and finally I have asked for the actual information. So this is all secondary data that I have collected from the industries, and then I have compared it for my benchmarking purposes. So here in all, I have contacted 12 industries. Out of those 12 industries, 2 industries went up to first and second step, but final step they refused. they refuse to share the data, so they are not part of this study. And 2 industries, they are not having formal cost of quality procedures, so these are not part of this. So finally there are 8 industries. The composition of these 8 industries are 3 large enterprises and 5 small, 5 belong to small and medium sized enterprises. For the thesis purpose, as the condition of those companies was that their name should not be exposed in the published literature and other things. So I have named them as Group 1, which represents large enterprises, and Group 2 represents small and medium enterprise, and I have named A, B, C and 1 to 5. But for this presentation, I can discuss the names. So these are the different companies that I have visited. Few are from the Aurangabad and few are from the Pune. The basic characteristics that I have seen for these companies, or to select a company, I have seen that they should have a progressive graph, means the sales should be increasing, they should be renowned names in their field, and they should be full quality conscious, they should have full quality systems in place. So this was the initial criteria, and these are the companies: Durowalls, Aurangabad, Ghrce Plastics, Kare Group of Industry.
Really, they are all manufacturing companies.
All are manufacturing except one.
Linked to auto mostly.
All are the automotive manufacturing cluster, because that is where most of our activity is happening right now.
Thermex.
Except Thermax. Though Thermax we cannot say manufacturing as per definition, because it is a EPC division. They are in the business of erecting the power plants. But still, I thought that what cost of quality practice they are doing. Okay, because I had contacted them, and they said that we are willing to share the data.
Now is Aurangabad Electricals, what they do?
Aurangabad Electricals is a Tier 1 company which supplies magnet to Bajaj Auto. So Tier 1 company, medium-sized company. Then Sri Pressings, it is a Tier 2 company which supplies the components to Aurangabad Electricals. It is a chain like this. Okay.
So when you say these companies are growing since when? Like say how many years?
Last 4-5 years.
Last 4-5 years.
Last 4-5 years. The criteria was last 4-5 years they should be double or triple of the growth and other things. Because ultimately they must share the data. That was a bottleneck of all these exercises. And this is a very sensitive data in the sense that all the financial things are there. So these are the questions that I asked through mail or phone, that on these 10 lines the initial interaction was done. Whether what is the name they are giving, because in most of the industries I have seen that they are not calling it as a cost of quality, they are calling it as a cost of poor quality. And they are just doing the failure cost analysis.
Before we go ahead, just one question. Did you look into the status of their manufacturing automation? Definitely
Yeah.
company, because somewhere advanced manufacturing.
Yes, it is one element.
These
Yes,
automation
automation is,
advanced manufacturing environment you are defined somewhere.
yeah.
Okay, the company
Automation.
have this.
Yes.
So are these companies meeting those requirements, or they are at different stages of?
They are at different stages. Few are fully atomized, few are partial atomized, few are willing or going for that. Because this is a broad spectrum which should represent all the small, medium and large. That was my intention at manufacturing progressing companies. So here my focus was on quality cost practices. Next. So I have found out whether they are calling it as a cost of quality, cost of poor quality, what are the elements used, how they are collecting, what are the reporting formats they are using, what is the use of this cost of quality data that individual organization is doing, and any company specific feature or observation. In this way, I have classified the. Now in Thermax, I have seen that cost of poor quality, they are having an elaborate system for that. Basically, they have designed and implemented a COPQ measurement system for project type of activities, where they have identified this list of poor quality areas they are going to monitor for each project, and they will be adding these values and they will be comparing the projects based on the COPQ. Now, for present study, this will not be much relevant. This will be relevant only when a manufacturing enterprise goes for implementation of some expansion activity. Suppose a already existing manufacturing unit is there, is it is going to expand. That time project type activity will come, and probably this information will be
They're
useful.
acting mainly a project management consultant, or they have their own.
They are having their own one because this information is
This
being
particular
shared.
division is like a project management consultant.
It is a project management consultancy, EPC division, but in Thermax, they have deputed one person. He is a transformation manager. He looks after this particular activity and he reports directly to VP Thermax. Now Tata Motors, surprisingly now I do not get a total access, official access, but in unofficial channel, I have seen their most advanced plant, that is a weld shop where all the robotized lines are there, and they are not going for any formal cost of quality. They have found out one area that there is a rework, lot of rework is happening, rework manpower is there. In the total shop around 39 people were there in a shift for rework, and rework is one part of this cost of quality. It is one element of internal failure cost, and under internal failure there are so many heads. So this is although they are having all the facilities and other things, they have focused on that only. That in a year's time they have targeted that this 39 should be reduced to 29. So for that they have decided a glide path. It was not a random glide path, but every month all these 39 people in what sections they are working, subsections in that industry. Then suppose in one section there are 8 persons, other section 6. So whether one person can be reduced in 8, and then for reduction what are the repeated defects occurring there, that they have found out, and then they are reduced like this. So
But
this information,
rejection must be mainly where they do welding of sub-assemblies, not in the body assembly. Body shop, when you say
in body shop also
where full body is assembled, there will not be rejections.
there are also rejections.
Full body
Yes, stage wise rejections are there, because in full body also there are number of stages. A line is there, complete line is there.
Are you sure? Because
Yeah, because I can show you the data shared. Below, behind this sheet, whatever data is there, that data is also shared with me. Then rejection means there is minor rework, and for that particular sub-assembly is taken. Different sub-assemblies come on the body shop, and then complete body is assembled. So for minor reworks, those are get rejected and rework is being done. Okay.
No. Sub-assemblies get rejected, not the body.
So sub-assemblies are getting rejected, reworked, and they will go on the conveyor line, right, sir? So
Once you assemble on the body rarely get rejected.
that doesn't get rejected, right, sir? You
Under
are-
very controlled
Yes,
environment,
yes,
lot
yes.
of fixed fixtures, and
Correct,
there is no
correct.
chance.
Yes, sir.
So you just remember this gap, that question.
Yes,
Somebody
yes,
may
sir.
ask you it also.
Yes, sir. Yes, sir. Yes,
The
sir.
rejection mainly in
Yes.
sub-assemblies, and
Yes, sir.
because sometimes you go, since you know someone there, look at the body shop.
Yes.
Body shop is entirely differently managed, and you find rejections are very, very different.
Yes. Now in Bharat Forge, I have found that they are using cost of quality methodology, but only 3 elements they are calculating. Prevention cost is missing, and if we see the rejection rates and their this one, the cost of quality, the graphs are parallel. Actually, it should not happen if we see the theory. Okay, so this implementation is not properly done. That is what my feeling is from all this exercise. Okay, rejection data and these are going on parallel, and prevention cost is not considered here. So, yes,
This 1 to 8 is a month, right?
yes, yes,
First month, second month.
yes. This is a monthly data. This is a scrap percentage.
Any reason on the 8th month it shows a peak.
That reason I have not investigated, sir. Just data shared by them. Compare whether they are using 3 elements,
Try
4
to
elements.
analyze. Try to analyze. You should
Yes, sir.
clear in your mind.
Yes,
Why
yes, sir. Yes.
8th month is which month it is.
Okay.
Whether it's some seasonal effect, some problem could be there.
Yes, yes. Okay. Then the second group, small and medium sized industries. So Sri Pressing, it is a small industry, 20-30 crore turnover. They are using, this is the most elementary level COPQ system. They are just calculating the internal failure cost. And simple thing, cost of defect into quantity, date wise they are creating the records. The next company, Aurangabad Electrical, this is a tier 1 company, this is tier 2. Actually, this is supplying material to this Aurangabad Electrical. They are having internal failure cost, external failure cost, both the things, because this is in link with a big organization. It is supplying directly to Bajaj Auto, right? So they are focusing this external failure cost also. Then Preciforge Gears Pune, they have shared the data. They are having only failure cost analysis, not other analysis, but shop wise they are having. Forging shop different, machine shop different, and vendor cost of quality they are finding out. So this is another aspect. The two elements are used, but across the plant they are using it. Tata Motors, I could get only information of body shop. I said that what is happening in other shop, he said that I don't know and I cannot disclose also. Okay, but here throughout the plant this is being implemented, and it is giving IFC data. Along with that, it is finding out PPM also. Okay, part per million rejection. These two things are only tested.
Forging is very high. Want to be there. Basic.
Yes, forging is high. Then machining and heat treatment, the cost will be high. Rejection will be in the same line, but cost will be high because value addition will be more.
You don't have data separately for machining and heat treatment. You don't have.
No, sir, because I have asked for minimum data.
Because machining rejections and heat treatment rejections are of different nature.
No, this is
No,
the
why-
data at the end of.
Heat treatment is
Means
different
after machining, heat treatment, and then final grinding, and whatever final data is there, for that it is being generated. Okay.
Normally rejection in machining will not be that high. Heat treatment sometimes if things are not, process is not controlled right.
Okay.
There could be because whole batch will get rejected. This is
In heat treatment, that may happen.
very
Yes, sir.
careful.
Yes.
And a lot of machining rejection also could happen if heat treatment is not
Yes.
done right.
But comparatively, forging and this PPMs are low.
Forging is a basic
Basic process.
basic process.
Yes, sir.
Maximum rejection will be there only.
Now, auto line industry, some other thing I have observed here, they do all the jargon of cost of quality, but they are
Just go back.
separate.
When you say forging rejection, just go back. They are the basic forging only or after rough machining also?
No, basic forging.
Only basic forging.
And then after that,
Rough machining,
HT, and then final finishing. So
that's why
this is-
rejections are more there.
Yes,
So rough machining is also, they taken in machining and ST. They are
yes, yes.
rejection project. Because even foundry rejection is there, foundry rejection. All those forging component rejection is also they are not done there.
So now this auto line industry, they have tried to put up all the things as per the standard. But when I see the data, the cost of qualities are very meager, 0.12 or 0.35 means they have suppressed the data. For the presentation only, they have done it. So this is what I have noted from that industry practice. That okay, they have listed and they have done classification like this, COPQ and COGQ. Cost of good quality, cost of poor quality. And this makes total cost of quality. But this is also a happening. They have got sheets of from 2008 to 2012 when I approached them. But it was initially around 0.5% and they said that we have brought it to 0.12%. But all the data is not convincing at all. So this is what I have observed in this data. Finally, the best company that I have observed is the Duro Walls, which is a Vero Group company which supplies all the engine walls to different, across globe they supply engine walls. This is a tier 1 company. Actually, this is a big group, but in this company only this separate practice is being followed. So they are having all the 4 elements: AC, PC, and EFC, IFC, and they have given this new approach: appraisal cost and prevention cost. That the basic problem in this cost appropriation is the payroll cost. A person working in the quality department, how much amount of his efforts and cost incurred by the company on him. That is one approach to proportionately distribute. Other approach is, I go by list of the activities. Suppose 15 quality department activities are there. Activity number 1, what is the time required and number of occurrences. But that doesn't give you a proper real picture. So I thought that this was one of the best method. This was a benchmark company which I have followed before the for my implementation. Okay, so these are the values. Here one important feature is he has said that cost of quality means he has said appraisal and prevention, this combined, and cost of poor quality, it is IFC and EFC. So these percentage should be are greater here. The prevention and appraisal is greater than the failure cost. So that is the indication of a system which is perfectly working as far as the COQ system is concerned. This is not found in other industries that I have studied. So I said that let us benchmark on this particular company and go for devising.
But what is the reason you say?
Reason, see, they have properly understood the meaning of each and every category. Accordingly, they have bifurcated the things and they have implemented it. Because I interacted with their quality manager for 2-3 hours. Then I said that what is the basis? So he said that we have actually observed what is the time of a particular engineer going on a prevention activity, what is the time going on the appraisal activity. Accordingly, we have decided these percentages. Okay.
Think about there is another reason could be because nature of product is such. This is a very crucial.
Yeah.
You know, engine wall is a very crucial.
It is a crucial thing.
And
Yes.
it has to be.
Yes. So that is an interesting observation, sir. That is an interesting observation, and that is what I am going to tell. This total cost of quality as a percentage of sales is much higher here in engine wall as compared to others. Others are reporting 2%, 3%. But this company is reporting it as a 2.75 is the internal failure and external failure is very bigger, 0.21, because they don't want any rejection at customer end. Then appraisal and prevention cost they are making as a 3% nearly. So in my case industry also the total comes to 3%, whereas they are having 6% here. So they have spent a lot of money on prevention and appraisal. That's why they are getting this proportion proper. So here my first part ends, first part of the study, wherein I have concluded that this particular fifth company can be a benchmark company, and whether I am going to implement it, I have to refer that company, I have to refer the framework that I have used, I have made, and I have to consider the characteristics. And my main focus was on working in a medium-sized industry. Why? There are some specific features of medium-sized industry. In medium-sized industry, you will find that multitasking is there at all levels, and there is
Only a little bit be careful when you say you're benchmarking this engine oil manufacturing company because nature of product, nature of final product is not same. Some are like forging.
Yes.
It's a basic
Yes.
manufacturing. Another is a finished. Engine oil is a highly finished product.
Yes, sir.
And which is very crucial
Okay.
for any engine operations. So saying benchmarking engine oil manufacturing with others. See, engine oil to engine oil is fine. You know, there are, let's say, 5 companies who are all making engine oil.
Right.
And then trying to say benchmarking one with another.
Benchmarking cost of quality practices, I mean to say that, not their values and other things. Say the different elements they have used. The way in which
Still trying to compare with the highly finished product, which is a highly precision product, you know, engine oil, with a one which are not, you know, that critical part.
it is very critical.
So that you have
Obvious,
to
sir.
be
Yes, obviously.
careful when you say benchmarking. You always
Okay.
say that these are achievable.
Achievable things. Okay, sir.
You try to
Yes, sir.
achieve maximum possible.
Yes, sir. Noted, sir.
We just
Yes, sir.
similar to product, similar to operation.
Yes. Now this was the proposed framework which I have shown, which here before implementation of this framework also these are few important things that we have to see. What are the quality culture in that particular company? Okay. We have to define the scope of QCMS. We have to define the scope of QCMS. Then, for practical implementation, we have to map the process there, and we have to identify what are the cost of quality things. Then prioritizing the proposals. And most important thing is the sustaining the water system I am doing. It should work. It should sustain. Otherwise, it should not get stopped at that point only once the study is over. That was one of the important things. So in pre-processor, I have collected this data for that particular company. This shows the company characteristics. Here, their logo is 100% client satisfaction through defect-free products, stringent quality norms. They are having ISO certification. Then quality and cost of quality status, they don't have formal cost of quality. So that's why I have chosen this. Methodology used here is a PAF methodology because ABC can also be used in the advanced manufacturing environment as indicated in the literature. But for that, the accounting practices should be in that line only. And that was a difficult task. So I have said that the most popular model I will be using here. Number of cost elements to be decided, I have referred this standard, also referred the company 5, what are the different elements they have taken, because from my previous study, it was found to be a best working cost of quality system. And to arrive the final list of cost elements, I have made use of these tools, departmental interviews, departmental studies, process mapping, and quality cost checklist. That we have done. Then cost data, as per the step in the previous step, the cost elements were decided. Accordingly, cost data is collected. Basically, there are two parts. One, which is readily available in the ERP system, means rejection is available, cost of rejection is available, so that can be multiplied and that can be obtained. So such type of data in 4 categories: prevention, appraisal, internal failure, external failure. And the 20% data, second part, which is the responsibility of QCMS, who is the manager central quality there, that he will take the appropriate decision to find out that proportions. The classification of data, primary classification is done on prevention, appraisal, internal failure and external failure.
This 80-20, can you explain again?
Yes, sir.
What is 80 and what is balance? You said 20%.
Sir, in next slide I will show you what are the elements which comes under 80%. What are the elements? That this is just an explanation of my model, and then I will actually show you. Now, what are the analysis? Different analysis can be done. For this study, I have done trend analysis and regression analysis. Next, report preparation, monthly frequency was decided for reporting. Then use of the data. So first use of the data was, the target was fixed by the management for cost of quality, and it was checked against that particular target. Second data was, this cost of quality per piece information is given to the department, costing department. And third was the trend analysis brought very important things. Some time back you have mentioned about the Bharat Forge, why that spike is there. So in this industry I have observed very interesting phenomena, that this is a seasonal product. First 5 months there is a heavy production, next 7 months there is low production, and in a conventional way, if I see all the literature, cost of quality trend analysis is done on continuous basis. A full year, full 3 years period, full 5 years period. Here, in the regression analysis, I have found that if I go by that method, I cannot regrade those particular regression values are not proper. But if I segregate them, high production months, low production months, and total period, so that is a uniqueness, what I can say is new thing that I found here. So these are study steps, sir. Can I skip them because of the time constraint? Because what I have done there, first meeting I have taken with the MD and 2 heads, the plant head and quality head. Then department-wise meetings I have done, and then I have explained them, because that was not available. What is the cost of quality? What are the methods available? Then why it is essential? Why it should be implemented in our company? What others are doing? I shared that these people are doing like this, and how to go about this tentative rules of the different departments. That is what we have fixed in the first step. Then I have myself obtained all the detailed information right from organization structure, functional work groups, product groups, manufacturing steps, process flow for the conduct of business, quality policies and practices followed, information available on the existing ERP system, and identified the data sources for cost of quality. So the product is a roll bond panel, which is a refrigerator component. Evaporator is made up of roll bond panel nowadays, and there are 22 models he has developed till this date. In any month, there will be a mix of 5-6 models based on the requirement. There are 5 main customers, all important customers here. Okay, and the total working persons in quality department were 18. Out of that, 10 were supervisor, engineer, manager, and 8 were the line inspectors. So that was a breakup. Now, this is a basic manufacturing process. There are 3 steps. One is the sheet metal working. Second, welding, that is the assembly of the tubes to that roll bond panel. And third one is the powder coating. So this was a completely automated system. Powder coating is an automated system. Then these are the 5 customers, Samsung, LG, Videocon and Ghrce. For them, they are making a roll bond panels. So these are the important steps, manufacturing steps. First is the panel making. These are the different steps. In that, the inspection is being done at this stage, and the inspection data is generated here. Here, inspection data is generated here. So 3 data are there: semi-finished, finished. Then, this is a list of different quality activities they are doing there. Some of them belong to prevention category, some of them belong to appraisal category, some of them belong to internal failure, some of them to external failure. Now that 80-20 I am going to explain. Now this is the 15 different activities these people are doing. There is a multitasking. An engineer may do this, engineer may do that, and at different levels. The manager, because that being a small company, so this distribution. Now what is the conventional method says? Say for example, a person is preparing a control plan. How much time it requires to take a control plan? Then that is to be quantified and multiplied by cost of that particular person. But as all these things are variable, that method will not lead to proper answers. So
This first piece approval is every day or every shift?
no. First piece approval is when the start of production line. That is new product is there, because there is a product mix and the same line is there. So when a roll bond panel is changed, then at that time the first piece.
Batch changes, they
Batch changes, it is done, and for new product also. Okay. Now these are the routine activities of quality department. The rejection data collection and uploading to the ERP system. Rejection analysis, they go for exhaustive rejection analysis. Model wise, there are 17-18 models. Then defect wise, there are around 18 different defects they have identified. So for one model there are 18 defects that are possible in 3 stages. So all this data is there. PPM analysis they are doing, and they are doing improvement initiative. The formal cost of quality practice is absent there. That we have incorporated. The reason asked, then they said that they are not aware about the details and they are open if it found feasible. So they actually involved in the case study and cooperated. Now this model, PF model only I have selected, these 4 in that. Directly available data, that next slide I will tell you, and data available to be quantified proportionately to different heads by QCMS in charge. And the data from the ERP sheet is extracted, and that is converted into the final formats that we have decided. So these are the data sources, sir. This I call it as 80% of the data which is available on the ERP. That is date-wise finished goods production, model-wise quantity, and what is the cost of that. Date-wise semi-finished, TIG welded stage production, date-wise rejection data, date-wise sales data. Okay, production data is different, sales data is different. Then model-wise rejection, this is fed by quality department. Countermeasure reports, that is based on the customer complaint, what activity has been done, that is a countermeasure report, and activity log of the quality department. These are the 3 things. And these other departments, whatever information is there, say for example, what are the training cost incurred. So he has to actually fetch that from the account department, It is not interactively available for him. Okay. Then payroll costs for the different people in the quality department. So this is a 20% that data where he has to proportionately distribute. Okay. And that distribution, this is what I told you, I am telling in this slide. Usual method of quantification of cost cannot be used because there is a variation in the pay scale. In 10 persons that are working in quality department as an engineer manager, there is a variation, the top person to bottom person. But there is a multitasking, role changing. Then complex calculation and possibility of duplication. If I go by that method, quantifying each event and measuring number of events and multiplying the cost and finding out, there may be a duplication of the effort. And system will be static because I will be taking present payroll cost, and after 6 months the payroll cost may increase. Okay, so that cost needs to be revised. So the approach used was a simplified one, and these figures are bifurcated as per this next slide. So this is that slide, a total payroll cost, the 10 department people, how they have been bifurcated. So this is being done by observing 15 days. What are their activities? So manager plant quality is 40% time goes in the prevention activity, 40% goes in the appraisal activity, and 20% of the time he has to look after the internal failure related issues. Means whatever rework is there, why rework is there and how to manage that rework. Whereas there is another post, manager central quality. His role is for a prevention activities and appraisal activities. Okay, so this is 60-40. Now this 15% is a percentage of total payroll cost. So if 100% is the total, it is 15. 40% of 15 is 6%. Like this, I have added here 60% of the total payroll cost should be reflected in a prevention cost. Okay, and this cost for my study, I have finalized this cost for calculation of the data. Okay, even in scope I have said that in further scope, even this data can be generated regularly, month-wise, and you can have more realistic system. So these are the elements that we have decided finally. 60% of salary of the engineers in quality department, cost of the external audit, cost of the training, 30% of salary of engineers in quality department, plus 100% salary of the inspectors and staff in appraisal, and 5% of salary.
Here slide does not show the external failure cost, where it is.
External failure
Just go
cost
back,
is there.
just go back.
Yes, it is there.
Just show, you go back where it is.
In this,
No.
okay. In this external failure cost, I have not mentioned. There is a specific reason. External failure cost, they are not being directly, payroll costs are being not expenditure. Payroll costs are already covered here as an internal failure cost. What we have assumed is where external failure cost, if some failure happens, then at that time, if some person is moving there, whatever actual expenditure of that only we are considering in external failure. His payroll cost we are not considered because those are not regular activities. Okay, some engineer will definitely go. So what is his time? What is the additional cost? What is the additional burden to the company? That is being reflected in external failure cost, not his payroll cost.
But where it gets accounted?
It is there, sir, in next slide. Cost of rejection at the customer end. If these many pieces are rejected, what is the cost? That is a direct thing. And cost of attending the customer complaints. These are the time, resources, actual traveling. So these are the incidences noted every month, and then actual cost is being taken over here, the external failure cost. Now this was a sample data sheet. I have got this study in 2 different periods. First initial period, I have decided that I have started this study in April 2013 up to December. Okay, 9-month period, I thought that this is sufficient. And this was a template that we have decided that we want this many information for each month. Okay, the first 4 values are the absolute values in rupees. Then it is a percentage of total, percentage of sale, total cost of quality. Okay, because this is total cost of quality, 31 lakh rupees something. And the total sale is, gross amount is here. 8 crore 97 lakh. So this percentage is important. So in this 9-month period, we have not gone for analysis. We have just gone for collecting the data and finding out this total cost of quality. So we have
This EFC, na external failure cost, na EFC.
external failure cost. Yes. So it is 8 lakh 90,000.
Sorry.
Because there are that time there was more customer rejection quantity was high. Here you can see it is 3149. Okay, and that is happening, sir, when he is trying to develop a new model for a new company. Then initially that happens. Yes. So those effects I could not go into that detail. Okay. So here the thing that I want to tell you is that there is a wild variation. That is the highest is a 4.92 here, lowest is a 2.28. Another thing, if we see the sale quantity, there is a lot of variation. You can see highest is 4 lakh, 3 lakh, and here it is 83,000 only. So then we have said that there is a variation. So the same data in consolidated form we have given here. So this was calculation for initial period, April to December. 9 months data is there, and these are the cost of quality values. And this was the distribution. Here prevention cost is 5%.
Wherever there are too much of variation in rejections, that you need to be ready with the explanation. Why?
Yes,
that variation.
yes, sir.
You can't say data is given like this. And
No,
this.
no.
That we have to be ready with
yes,
that.
yes, sir. That I will explain, sir. Now here, this is a component. External failure cost is 21% of the total cost of quality. Internal failure cost is a 67%. 5% is a prevention cost and 7% is a appraisal cost. Now this is not that healthy actually. This should go on increasing, prevention and appraisal. Okay. So this was the initial study period. Then the observations from that graph. Here it was found that average monthly sales is 5 crore, whereas the minimum and maximum there is a lot of difference. Okay. And PC and AC are much less than the usual proportions mentioned in the literature. That was the finding in the first portion. So overall observations, all the quality cost data is available in the different formats and different places. So it has to be properly collected. Okay. Lot of data is available on day-wise level also. And some data we have to go for monthly. Now this is an important observation. In case industry, due to the seasonal product, large variation is there in the production and sales figure, month on month. Effect of this variation of cost of quality needs to be established. That is what I have found, and that's why instead of restricting a study there, I have extended a study period to 2 more years. That was the basic logic. So up to December 2015, I have extended the study, and here you can see the gross sales variation. 1 month it is 2 crore, 1 month it is 12 crore. Okay, the 5 months we are identified as January to May as a high production months, and the remaining, that is June to December, those are low production months. So all my studies are in these 3 periods. One total period, other high production period, third low production period, and then we will compare. So these are the trend analysis, wherein all the 4 components are shown here in this particular bar chart. If we compare the similar periods, say June 13, June 14 and June 15, it has been observed that we have started the study here. There is a slight increase in the cost, and then there was a drastic reduction in the total cost in absolute amount. Okay, so this is reflected. They have installed, or they have initiated number of quality improvement programs in this period. There was one particular defect, that is debonding, and for that they have worked, and that work was successful. They have changed the machine and other things, so this has been reduced. Okay.
No, you say they initiated the quality. What is that?
Quality improvement program.
Quality improvement program.
Yes.
What do you mean by this? What kind of
Quality
program?
improvement program means wherever there is a rejection, find out that particular trouble area, then knock down the problem area and take the initiatives, improvement initiatives. So quality improvement initiative. So now this is a rejection trend. and this is the total cost of quality trend across the total study period. Okay. Scatter is more in rejection data, maybe because of some localized results in a particular month. But overall, this will be slightly smooth if we convert that information and take other information, and total cost of quality is comparatively smooth. And over the study period, it has been observed that the percentage rejection is reducing as well as the total cost of quality as a percentage of sales is reducing. Then these trends, appraisal cost as a percentage of total cost of quality is gradually increasing. Trend line is showing like this, and the failure cost trend line is reducing. Okay, this is our two parts of same coin, because half will be that and half will be this. Then now this is a consolidated cost of quality data. Here one more table is there, cost of quality per piece. Okay, this was an important thing from their point of view. Before this exercise, they used to consider the cost of rejection as 2 rupees, 3 rupees per piece. But I have shown that it is much more than that.
September 14,
yes,
29.
Yes, here,
September 14.
yes, this is the reason. September 27% is the external failure cost, which is more than and 61%. So here there is a one lot which has been rejected totally at the customer side, and because of that, that has been increased. Okay. So
What reason they say? Why was it rejected? Because of raw material problem, or what was it?
That I cannot exactly tell right now, sir. But there was a complete lot rejected. That is what is being.
No, wherever there are major deviations. Because
yes,
this is
we
one
have
of
to
the
focus.
presentations when you go for the final one.
Yes.
Wherever there are major deviations,
Yes, sir.
try to find out the regions.
Yes.
That should remain
Yes, sir.
in your mind, because they are the question anybody will ask you.
Yes, sir. Now this is a consolidated information, different periods, what is the percentages. They will just show the trend, high production, low production, April to December, year 2014, year 2015. Okay, so in 2015 I have got these values lowest, total cost of quality, and average value is 2.85. Same thing is tabulated. In bar chart it is being shown. Total cost of quality in percentage sale and cost of quality per piece. So in this region it is minimum, but still whatever they used to calculate, it is more than that. They used to consider it as a 2 rupees, 2.5 rupees, but it is more because they have just considered the cost of rejection. Now regression analysis I have done for these periods, as I told you, January to May, staggered for 2 consecutive years, and high production, low production months, and total period. Okay. Sir, now these are the R square values that I have got for regression. Study period, say normal, 2013 I have got a 9 months period. It has not shown any trend because R square value is very poor. Okay, so that point only I have stopped. I have said that why this variation is there. The linear, normally in linear regression, we can fit this data. That is what literature says. Whereas it is not fitting. That's why the conclusion was increase the study period because of the seasonal variation. Then 2014, this data is R square is 0.5248. Then overall period, this data is once again R square value is poor. Whereas for a high production, I am getting R square value good for the total period. And for low production, I am getting this slightly better than the normal thing. Okay. Then I have got this regression because percentage rejection is the data available on shop floor, and from that if I want to predict what will be the cost of quality, I can use these equations. Okay. So for these 3 periods, I have developed these 3 equations. This is for a high production period, this is for the total study period, and this is for low production period. So it is found that if we go by low production and high production periods, then we can predict probably the values more closely. Those values I have displayed. Now here, this is actual total cost of quality. This is predicted by the equation, and this is a residual. For high cost months, for low cost months. And now this is a final table where we can have a comparison. Here these are the predicted values of total cost of quality. These are also predicted values of total cost of quality, but these are predicted based on the total period. And these are based on a high or low, depending upon which month. And then I have put these bold things. So you will find that once the system gets stabilized, then it is better. Whenever there is a fluctuation in the seasonal fluctuation in the industry, you have to bifurcate the data in high production and low production months, and accordingly we try to find out the trend analysis. That will be much better. That was the conclusion. So this was the trend analysis for getting the values of total cost of quality if I am having the rejection value. Similar trend analysis I have done for another one, that is to predict the cost of quality per piece if I am having a percentage total cost of quality percentage sales values. So this also I have done. But here you will find that R-square values are much better, because that is just another form of representing similar data. Actually, total cost of quality as a percentage of sales and cost of quality per piece, they are nearly same. Okay, but still, what is the logic? If I am having a rejection data, I can predict the total cost of quality. From total cost of quality, I can predict the cost of quality per piece. So that is what. Now, similar tables for this combined table. Now, this is to just inform that after my study period also, he has continued the practice. He has shown me this mail that next 6 months this was a trend in the industry. Though I have not included this analysis part, but for in January to say June 16, he has sent me data that they are going for this particular thing. Now, we have done this exercise for that particular plant, fine, but whether the method works or not, so for that I have extended this method to 2 more plants which are working in the same group. That is the suggestion probably you have given me, sir, in last progress seminar. So that I have extended it in 2 companies, but there I have restricted it to just a trend analysis. So the important point here is the cost values are much less here in these 2 plants, Elegant and Alpith Metals. Okay, these are 2 sister concerns, and here this is a rejection trend and total cost of quality trend that is being done. Now this is interesting here, sir. Here failure costs are much less and appraisal and prevention costs are much higher in these 2 industries. So probable reason is that Elegant and Alpith, both the companies, Elegant, it is a completely atomized paint shop. Okay, so there we are getting the proportions, paint, the failure cost and this prevention and appraisal in line with each other. Yes, that is what we have got in these 2 trends. So now, coming to the conclusion portion of my seminar, major findings of this study. The outcome of this exercise was a framework for QCMS. That is the first outcome. Then, another thing, literature alone cannot go for any research study. That is what I want to say. We have to go for insight of the actual practices. And that is what I have incorporated here. Because that information was not available in open domain, I have to go and search in the industries, and that I have done. Then framework developed was utilized. Inputs from industry studies were incorporated, and study was quite fruitful for that industry. The input of the output of this study, that is being utilized for total percentage cost of quality and cost of quality per piece. That is they are regularly using. Now contribution to literature out of all this work, a review paper which gives you an exhaustive idea about up to that particular point what are the happenings in cost of quality. Then for 8 studies, industry studies, these are documented, and I have got one paper on this also which has been accepted. Now I am waiting for publication. And last but not least, if somebody want to implement this cost of quality methodology, he can use my thesis as a primer, he can start and he can implement. Implication to industries. Methodology is an eye-opener for all the stakeholders of organization because quantification of quality lapses is what is being done in the quality costing. Whatever quality lapses are there, that is quantified, will lead to a greater interest of upper management. Now, the upper management has not given any resources. Using existing resources only, we have done this. So, if now they will put more resources because this is finding useful, and there will be some accountability in the staff because some costs are being assigned to them only. Then, this is an easy to follow procedure outline will help industries to undertake the cost of quality methodology implementation in absence of proper standard. Standard is not being revised from last so many years, so it can be used. The method suggests maximum utilization of information technology infrastructure available with the organization. There will be reduction in the subjectivity and ad hoc decision making in quality costing issues. That will happen. This gives vital inputs to the costing sections, thereby possibility of bottom line growth of the organization. Also provide financial justification for implementation. Can be incorporated in the future MIS ERP software upgrades in a refined way to reap further benefits. Lot of interaction that now QCMS in charge is doing, that can be automated once it is finalized. These are the considerations for generalization. It is a medium-sized growing industry with established quality culture, flexible work environment with multitasking, formal cost of quality system is not there, advanced manufacturing environment, which means IT infrastructure consisting of network computers, ERP MIS softwares having integrated databases for different functions, such as production, quality, design, purchase, marketing, HR, all these should be integrated, and the industry should be moving towards automation. So these are the traits of the advanced manufacturing environment. If these traits are there, then we can incorporate this model and move further. So literature review conclusions. There is a need for proper mechanism to educate, facilitate and implement cost of qualities in a target industry. That is being reflected in so many literature findings. It is equally important to know what are the reasons for non-implementation of cost of quality. There may be different reasons industry-wise. They are not willing to implement that. For the industries where cost of quality practices are already implemented, there should be a continuous refinement to get the desired benefit and sustenance. And effort should be directed towards utilization of available information technology infrastructure for implementation and sustenance of cost of quality practice. Now, actual study practices, the conclusion is out of all the companies that are studied, company 5, that is Durowall, use the cost of quality methodology as per given in the standards or available in some of the published literature. Values reported indicate that some of the prevention and appraisal costs are nearly equal to the failure cost, and that indicates its proper working. And in case study, prior to this exercise, this is one of the important things for industry. They used to consider cost of quality per piece to be 2 rupees. For panel costing less than 250 and panel costing more than 250 rupees, they used to consider it as a 2.5 rupees, whereas the actual values are much higher, and that is being a finding. So at the time of costing, they are taking care of. Another important thing, they came to know now that say on an audited profit value of say 5 and 6% of the sales, we are saying that cost of quality is 2%, 3%. They came to know that this is a very high value. And they have to work on that. So that is a finding. Finally, as the last phase of study to validate the model and methodology, cost of quality process is implemented in 2 additional industries under the same group. compare both trains for elegant are slightly better than Alpic metal, but both are much better than flat metals. That was the conclusion of comparison. The limitation of the study: they have extended full liberty to extract any data from the existing ERP, but with the caveat that no change should be there in the ERP system, no change should be there in the accounting system. That was the limitation. And second, if a proper interface is designed for the existing system, this would have been much better. But he has promised that when he is going for a upgradation of ERP or changing, he will definitely think, and that time he will take inputs from me. The future scope. Now the data points were very limited. We have seen high production months in 2 years only we get 10 months. In 10 months, what is the regression curve we are getting? And if I get weekly data, then I can predict the things more properly. So this is first suggestion: weekly calculation of the and reporting of the cost of quality data. Second, capturing and calculation mechanism. And third, extension of activity to complete supply chain. That is now extension of the activity to complete supply chain means now it is restricted to that plant. Now it is to be extended to his supplier. His cost of quality is also to be considered, and to say vendor and supplier, both sides. So there should be an integrated framework. That can be the future scope. These are the references, and at the end, I would like to acknowledge the contributions of different people in this particular work. There are so many people. Firstly, for our regular this progress seminars, Tidke sir, Monty sir, Ghrce sir has given valuable contributions in the 8-9 progress seminars that we have done. Then here, actually your name should also come, sir. Pundir sir, because you were there for 9 progress seminar along with Andare sir. Then for review paper, Gunasekaran, he has given very valuable input for changing the content, refining it. Then that was my first experience of writing a paper for such journal. Then I am very much thankful for Lakhe sir for the inception of this concept to this level. He has interacted many times and suggested me directly or through my guide the different things. Then these are the different industry people: Ashok Kale, Vinod Diwan, Atole from the Kale group of industry, Miniar, Associate Vice President, Bureau Walls, then Modani Shri Pressings, Ingre, Aurangabad Electricals, Joshi, Vesi Forge, Pune, Mandikar, Tata Motors, Mr. Purohit Bharat Forge, Kulkarni Avinash Thermats, and Godaji, Atoline Industry, and 3 more plants I have visited, but they have not shared the data. But they have shared some information, that is Value, Pune, then Kongsberg, and Metalman, Aurangabad. So with this, these are my list of publications. First is a journal paper, and these are 3 conferences that we have done. Thank you, sir.
I think overall it's a good effort made. You got a lot of insight. The last time we interacted, I think you added a few things in this.
Yes.
Only somewhere you can bring out. You said that directly, indirectly somewhere you mentioned about it. But when you study in depth those 3 industries, elegant and clad metal and one more, Arpita. So Arpita and clad metal has a different type of manufacturing environment vis-a-vis elegant.
Yes.
Well, they may be same group company, but environments are there. Type of products are different. Type of process, manufacturing process is different. That's why you see this confusion of PC and AC vis-a-vis FC.
Yes.
PC and AC is higher in case of elegant, and FC is low. What you want at the end of the day, FC should be low, right?
Yes, yes,
You all want
Yes,
this or fail.
yes,
Better put some more money in PC and AC.
yes,
So by nature of this, that's why this difference is coming up. Somewhere it should remain in mind clear. Best scenario is only where FC and AC are higher. No, sorry, PC and AC is higher than
Then,
PC with FC. That is the best scenario.
yes,
And this is easily achievable in process plant because
yes,
they are well maintained and by virtue of being a process, people take care a lot.
yes,
But whenever standalone machines, standalone equipment and those things comes up, where handling is more.
yes,
In a process plant, handling is of different type. There is a lot more control, while here it is not.
yes,
And this is where this problem comes up. So everybody wants to achieve like a process plant.
yes,
So this somewhere along with Professor Jadvi, you can find it out. Okay?
yes,
How you can at least highlight that part of it. You have enough data and you have mentioned it also.
yes,
But rather than generalizing all three together, you can generalize
Okay.
a little bit in a different way also. Try to generalize. Other companies, I don't know because these three happen to be now medium industry only.
Yes.
Even though you took two large enterprises also, but I think you don't have much data of those large enterprises.
Yes.
So think what you still need. Have you got data from those two large enterprises or not?
Yes, I have got data restricted to whatever I have presented. One year data, that period data.
Okay, but largely your findings are depending on the medium enterprises.
Yes.
That is the base. So I think more and more emphasis you can give to those medium enterprises.
Yes.
Because large enterprise is a very small portion of it. The moment it's a large, people think contribution will also be large. While it is other way around. So you can definitely SME. So try to
Yes, sir.
you play down a bit that large enterprises thing. That happen to you cover.
Okay.
But your primary aim was, in my opinion, was more of a SME is what Professor says.
Yes, sir.
This is what you can look into it. But I said, finding and all things have come out well. He has proven also after his study also 6 month data you have taken it.
Yes.
And if you can keep track of them and by the time you have your final whenever that also you can prove it further. If you can get the data and in the final presentation you can show that also the trend is still
Yes.
going better. If not going better, don't show it. If you become better, then only show it.
Okay, sir.
Only one more thing you can think about. It may be there somewhere in your thesis. I have not seen your whole every time. I only came once earlier and today. Whether on a timeline you have shown the how cost of quality importance has gone up or down at a different area, different sectors. You had taken a literature review from last 20 years nearly. I think 85 onward somewhere.
Yes. Yes.
I see some 60 papers also there.
Yes. Yes. Yes.
But 85 onward, I think you have very lot of papers you have taken.
Yes.
So is it possible you can see on a 5-year period what all factors
Yes.
has gone up in our importance and some have gone down?
Okay.
That one unless you can do it and maybe either you can include it, of course after talking to the professor you can think over.
Yes.
Because that is a one analysis can be a
Yes.
good analysis. If it is done, it is fine. If it is not done, you can think over. But that can be done. Because that shows some of these factors how they gain in importance by the researcher over the years and how it has changed over the years. Because you have gone right up to 2013, I think.
Yes.
Your
2012.
literature reviews up to 13 is gone.
Up to 13.
Yeah. So sometimes in some places it remains highly relevant.
Yes.
So that will give you further confidence that rather than saying that no work was done, if you could showcase on a some sort of a, let's say, I don't know, every 5 years, whichever scale is thing, different authors have shown cost of quality, what all parameters they have shown, what all they consider,
Yes.
and how they showcase it. You can think it over.
Yes. Sir.
Or if some nomenclature have changed, you can always highlight those also.
Yes. Sir.
That will show that you have been very strong. You have been strong in literature review, but that will show also you were strong in literature review. That is always think it over.
Okay.
Because I had seen you have to basically
It's good. He has done validation also. He has done the things also.
yeah, he has done very exhaustive work.
Very Ghrce, it has come out well now.
Yeah.
Last time we
He
had
has
it.
put in 4.5 years in the industry. Basically, he means his registration will not end up. Because he has to extend that study to get the better trend analysis.
So collecting
That's
those
why
data.
3 years, 3.5 years, he has collected the data.
getting those 2 years continuous data from one company.
Yeah. It's very huge work.
Yeah, you must set definitely good contracts here. Otherwise, they will not give you.
Because otherwise they don't share. Because I have also done my PhD in cost of quality in India, but in small scale industry. When I worked with Dr. Mohanty and Dr. Nati. So I had with one facility that in France.
Yeah.
But it's very difficult to get the data. So yes, main the new contribution which we have done is that lot of actual industry practices of 8-10 industries have been added. Okay. Before building up the framework, that was the most important contribution.